Hello, my name is Caroline Salas, and this is my hopper. It is supposed to move by compressing and latching, and then I release the latch, and it moves.
Water has four main forces acting upon it: buoyancy, weight, drag, and thrust. In order for my hopper to move in water, my thrust needs to be greater than my drag. This is what I'll be calculating today. My hopper is compressed and then released. This is experimentally how I found my spring potential.
I found out how much newtons it took to compress my hopper into its potential state. I used a Newton meter spring scale, which I do not have pictured here, attached it to one side, kept the other side stationary, and pulled until it was at zero.
My spring potential equals 1.5 Newton meters per second squared. I set this equal to kinetic rotational, and I solve for angular velocity, which comes out to 544 radians per second. I solve for half of my angular velocity to determine only one side of my hopper, which comes out to 272 radians per second. Next, I calculate the force of drag. The force of drag is the coefficient of drag times rho divided by theta from the integral of 0 to theta surface area in respects to alpha with the velocity in respects to alpha d alpha. My variables include the coefficient of drag, which has been found by NASA as this is a streamlined half body at 0.09. Rho is 1 gram per milliliter, as this is the density of water. From this, my force of drag equals 12.6 newtons. Thrust is defined by momentum over time. Momentum is defined by mass over velocity average. Thrust then equals 2.6 newtons. My thrust is less than my drag. Since my drag is greater, that means my hopper will not be able to overcome the force in water.